and it asks us which is the solution to the following equation. So we need to start by combining like terms on either side of our equation. So if I start by combining the x's on the left, I get negative 5x plus 9 is equal to, and then on the right-hand side of my equation, I also have some constants I need to combine. So I have a negative 5x, 12 minus 3 is also plus 9. If you take a look at your equation at this point, you have the same thing written on the left and the right side. So at this point, you might recognize that it's infinitely many solutions. However, you could keep trying to solve, and if you subtract and try to combine like terms, if you subtracted by 9, the 9's would wipe out. If you added the 5x to either side, they would cancel out to 0, and you would ultimately end up with 0 equals 0, which is true always. Okay, for question number 2, the length of the shortest side of a right triangle is 5 inches. I'm going to just start by drawing myself a right triangle. So I'm just going to indicate the right angle, and the way I drew it, the smaller side, I'm just going to label that as 5. It tells me the lengths of the other two sides are represented by consecutive odd integers. So what I know about right triangles is that the hypotenuse is the largest side. So if I'm going to have two consecutive odd integers, which I might say, if I start with x, the first one would be x, the second one would be x plus 2. X plus 2 would be the larger of the two, so that has to be my hypotenuse, and x would be the other leg of this right triangle. Then I have to remember my Pythagorean theorem that tells me that a squared plus b squared is equal to c squared, a and b both being the legs of the triangle. C is representing the hypotenuse. So if I plug into that, I would have x squared plus 5 squared is equal to x plus 2 squared, which we have here for choice 4. Okay, for question 3, we have the formula for the volume of a cone represented as 1/3 pi r squared h. They tell us r is the radius, and they want us to get the radius of the cone in terms of the other. So let's find that r in terms of h and v. So the first thing I want to recognize, I might rewrite my equation to make it easier to manipulate. I'm going to get rid of the 1/3. So in order to get rid of that multiplication of 1/3, I'm going to multiply by the reciprocal, which would be 3/1. And that will cancel out that fraction to 1. So now I end up with the equation 3 times v is equal to pi r squared h. I have to recognize here that the pi and the h are both multiplying r squared. So if I want to undo multiplication, I need to use division. So I would divide by pi h. And then one last step, I now have 3v divided by pi h is equal to r squared. To undo a square, you need to use a square root. Now normally, and we've talked about this in class before, when you use a square root in an equation, you do need to indicate the positive and the negative. However, because this is talking about the radius, it's a measurement of something, I'm going to just consider the positive root. So I'm looking for the square root of 3v divided by pi h, which is choice 3. Okay, for number 4, which equation could be used to solve the given problem? It says if 4 times a number is increased by 12, the result is 2 less than 5 times the number. Okay, as we read this question, we're going to notice here that there are 2 places where we saw the word is, and I just circled both for us. This one's a little hard to see, but I circled both for us because I want to identify which one represents our equal sign. So they're telling us if 4 times a number is increased by 12, the result is. So this is actually referring to the answer. This is not, and I can only have one equal sign in an equation. So if 4 times a number, well, let's let x equal the number. And if 4 times that number is increased by 12, remember, is increased by would be addition, the result is. Okay, so now I have an equal sign. And that result is 2 less than 5 times the number. And remember, this less than is that reversal. So even though 2 is coming before the word less than, it's going to come after it when I write it. So 5 times the number would be 5x, and then 2 is less than that. And this came out to be choice 2. Okay, for question number 5, I went ahead and typed some things in to help us out. So we were given 4 different numbers represented by L, M, N, and P, and we were asked which expression would result in an irrational number. So you'll notice there's 4 choices, and we have 4 calculator readouts. So for choice 1, it said to take n times p. Well, n is the square root of 16, p is the square root of 9. If you notice down here, if we multiply n times p, we get 12. 12 is rational, it's an integer, so that would not be our choice. Then we go on to n plus p. So now I'm adding the square root of 16 plus the square root of 9, and I'm getting 7. Again, an integer, that's a rational number. Then I look at choice 3, L times L. Well, the square root of 2 is what L was representing. So if I take the square root of 2 and I multiply it by the square root of 2, I get another integer, 2. So at this point, we are selecting choice 4. But the reason is if we take 3 rad 3, which is m, and we try to add it to p, which is the square root of 9, what we're doing here, the square root of 9 is irrational. This 3 rad 3 is an irrational. And when you add a rational and an irrational number, you're going to end up with something irrational. Okay, for question 6, it says if t is equal to -2, then what is 3t squared minus 2t minus 1 equal to? So let's come over to the calculator. I'm going to store -2. So remember, when you store a value, you type it in first, then you hit the store key, then you hit the variable x and hit enter. So now my calculator associates -2 with x. I'm going to type in this equation, or this expression, 3x squared minus 2x minus 1. I don't have to worry about parentheses. I can just hit enter. It will evaluate it for me, and we get 15. Choice 3. Okay, question 7. It says John has 4 more nickels than dimes in his pocket for a total of $1.25. Which equation could be used to determine the number of dimes in his pocket? So if we want to think about this, we can do our type, number, value, total chart. And again, this isn't going to be that long, because we only have 2 types of coins. We have nickels and dimes. So I'm going to give myself nickels and dimes. Okay, if I look at the number, it says he has 4 more nickels then he has dimes. So dimes would be my x, nickels would be my x plus 4. The values would be 5 cents for a nickel, 10 cents for dimes. If I want to write the total column, remember you just take your number times your value and it's equal to your total. So if I take that 0.05, I'd be multiplying that by x plus 4 in parentheses, and 0.10 times x, you do or do not need parentheses there. They tell us then that he had a total of $1.25. So I want to take that 0.05 times x plus 4 plus 0.10x and set it equal to $1.25. I want to take a look now at my choices, and that matches up with choice 2. They just wanted you to come up with the equation for it, and if you were trying to find x, this would be the equation you would use to do so. Okay, for question number 8, I'm just going to put a little room here. Okay, we are solving for x. So we're given the fraction 3/5. We're multiplying it by x plus 2 and setting it equal to x minus 4. So if I maybe looked at this and thought, oh, I can multiply by the reciprocal, the problem with that is that I'm going to end up kind of in the same predicament. I'm going to end up multiplying x minus 4 by 5/3, which is really no different than having 3/5 multiplying my binomial x plus 2. So I'm going to take a different approach and start by distributing that 3/5. So I'm going to end up with the equation 3/5 x plus, if you take 3/5 and multiply it by 2, you should get 6/5 and set it equal to x minus 4. Now I have an equation where the variables are on both sides and my constants are on both sides, so I'm going to try and combine them. So we can start by maybe taking the 3/5 x and subtracting it to the other side. Again, this might not be the exact step you chose to take, but we should ultimately end up with the same result. We get 6/5 is equal to, if you take 1 and you subtract 3/5, you should get 2/5 x minus 4. Now I want to combine my constants, so I'm going to add 4 to the other side. If I take 6/5 and add 4, and we should get 26/5. And that's equal to the 2/5 times x. Now I'm going to use that reciprocal. I'm going to multiply by 5 over 2 to undo that reciprocal and multiply and get 1. And then on the other side, I'm also going to multiply by 5 over 2. If you cancel or simplify, the 5s would cancel here, but if you simplify this piece, you'll end up with an x value equal to 13, which was choice 2. Okay, for question 9, it says, which property is illustrated by this equation? Well, I'm taking the number 4/5 x, I'm adding something to it, and I'm getting back the same thing. So the number 4/5 x is not changing its identity by being added with the number 0. So the additive identity property tells us that if you add 0 to a number, you do not change that number's identity. Okay, for question 10, it says to solve the given equation. So we have a fraction equal to another fraction. This is when we're set up to cross multiply. So if we cross multiply, we get 4 times y plus 1 is equal to 12 times y. I'm going to start by distributing my 4. So I would get 4y plus 4 is equal to 12y. I'm going to subtract this 4y. I get 4 is equal to 8y, divide by 8, and we get a y value of 4 over 8, which would simplify here to give us a positive 1 over 2, choice 3. And question 11 here, which equation is an example of the associative property? So remember, associative property means we're changing an association. So the parentheses on one side of the equation are going to then change association on the other side. So if I take a look at question 11, the first choice, I have x, y, and z, and x, y, and z. So the order didn't change, so I know it's not the commutative property. If I look here, I can first see that x and y are being associated, and z is off on its own. And then the other side of the equation, y and z are being associated, and x is now on its own. So this is changing association. This would be my associative property. Choice 2, just to look here, what they did here was they changed the order of x and z, so that would be the commutative property of addition. Choice 3, they distributed this x, so that would be the distributive property. And choice 4, they took the x plus y in parentheses and changed order with the z, which would also be another form of the commutative property. Okay, for question 12, it says if x plus 4 is an even integer, which expression would result in the next consecutive even? So remember, when we go from even to even, if I were to write out a few consecutive even numbers, I want to think about the difference it takes to get from one to the next. So I'm adding 2 to get from even consecutive integer to the next. So if x plus 4 is my first consecutive even, and I want to go to the next one, I would be adding 2. So if I simplify this, I would end up with x plus 6, choice 4. Okay, and the last multiple choice question here, which statement is not always true? The product of two rationals is rational. Well, that's true, and if I want to just show an example, 2 times 4, both rational numbers equals 8, also a rational number. You could take any, take some fractions, 1/2 times 1/3 would give you 1/6. Again, still rational, so this will always be true. We want to look for which will not always be true. Choice 2, the product of an irrational and a rational is always irrational. Okay, well, I can definitely say that that could be true. If I take an irrational number, let's say like pi, and I multiply it times 2, I'm going to get 2 pi, and you would get the decimal equivalency of that in your calculator, but that will come out to be irrational. However, if I take an irrational number again, let's say like pi, and I multiply it by the rational number of 0, I'm going to get 0 because of that 0 product rule. Anything times 0 is 0. That comes out to be something rational. So even though this is sometimes true, it's not always true, which makes choice 2 our answer. Okay, so for number 14, they're asking us to express C in terms of Q and D. My first step, I'm going to just rewrite this. Q equals C plus D. D over 2. Now, again, I'm trying to solve for C, so I like to just circle this C to make sure I know that's what I want to isolate against by itself. So my
first step is I want to get rid of this dividing by 2. To undo division, I'm going to do multiplication and multiply by 2. That lets me cancel both of those out. What I do on one side, I have to do on my other side. So I end up with 2q equals c plus d. Again, I want to isolate this c, so I want to get the c by itself, so I need to move this plus d. So to move my plus d, the inverse is to subtract d. And what I do on one side, I'm going to do on the other side. Now, we can't actually subtract 2q minus d. So we're going to just leave it like that, 2q minus d. And over here, these cancel out, so we get c by itself. Now, always double check. Express c in terms of q and d. So we have c by itself, and it's in terms of q and d. So this is your final answer. Okay, so for number 15, we want to find 2 consecutive integers such that the larger is 9 more than twice the smaller. So first we want to set up our little table. If we have our first consecutive integer and our second consecutive integer. Now we're talking about consecutive integers, so if x is my first consecutive integer, to get from one consecutive integer to the next one, so I'm talking about numbers like 1, 2, 3, these are my consecutive integers. To get from one to my next one, I'm just going to add 1 each time. So to set up this second consecutive integer, it's just going to be x plus 1. Let's have some space over here. So now I need to set up my equation. So they're saying the larger. So if we look at our 2 integers, x plus 1 is our larger integer. So I'm going to have my larger, x plus 1, that means I have to put my equal sign. 9 more than twice the smaller. So 9 more means I'm going to have to add 9. What am I adding 9 to? Twice the smaller. So twice the smaller can be represented as 2x, because x is our smallest integer. And then I'm going to add 9 to it. So that was setting up the equation. Once we set up our equation, we want to get x by itself. So I'm going to move my variables. I get 1 equals x plus 9. And I want to move this 9 over. So I get an answer of x equals negative 8. Now be careful, now that we have that negative 8, we need to make sure that we're identifying what these 2 integers are. So our first integer is a negative 8, and if we add 1 to that, our next integer would be a negative 7. So make sure you always go back and fill in your chart, that way we're completely answering the question. So number 16 asks us to solve algebraically for x. So if we look at this, we do have some fractions going on. So the first thing we want to do is look for our LCD. So I wrote out all of my multiples of 3, 7, and 21, which are my denominators. And I want to find the least common denominator out of all of these. So if I list out the multiples, I see that my least common denominator that they all have in common is 21. So my LCD is 21. So I'm going to take each of these and multiply them by my LCD. So I'm going to multiply this by 21. Let's rewrite this. Okay, so I just rewrote this just so that we have a little bit of room. And again, I found my LCD of 21, so I'm going to multiply each part of this by 21. And make sure you multiply every single part by 21. Now we're going to want to reduce. So if we look at 7, how many times does 7 go into 21? Well, that goes in 3 times. And 7 goes into 7 once. We look at 21 and 3. How many times does 3 go into 21? Well, that goes in 7 times. And we're left over with a 1. And 21 goes into 21 once, so we're left with 1. Now we want to rewrite our equation. All of our denominators are now 1, so now we only have to worry about our numerator. If we take 3 and multiply by our 1, we're left with just 3. We want to take this 7 and multiply by the 2x. So that's a positive 14x. And then, since this is just a 1, 1 times our 15x minus 3 is just 15x minus 3. Now that we have this, we can just solve our equation. So if I subtract 14x, these cancel out, so I am left with 3 equals x minus 3. If I add 3 to this side, add 3 to this side, these cancel out, and I am left with my answer of x equals 6. So number 17 wants us to solve algebraically for x. So if we look here, we have this 3 in front. I need to distribute this 3 into the x and into the 7. And over here, even though there's not, that's about, even though there's not a 1 here, I need to distribute this negative 1 into the 2x and a negative 1 times our 9. So if we want to rewrite this, we're going to have 3x plus 21 minus our 5x. We just need to bring that 5x down. And that's going to equal to 12 minus our 2x, or negative 1 times a positive 2x gives us a negative 2x. And a negative 1 times a negative 9 gives us a positive 9. Now we want to look at this and combine their like terms. So I have a 3x and negative 5x here. So that's going to give me a negative 2x. Don't forget to bring down this 21. Equals, over here, if we want to combine their like terms, we have a 12 and a 9. So that's going to give us 21. And again, just bring down that minus 2x. Now we want to kind of move some variables over. So if we subtract 21 and subtract 21, over here these cancel out, so we get a negative 2x equals, well, these cancel out over here too, and we're going to get a negative 2x. Now at this point, I should see that I have the same thing on both sides, but if I want to continue, I can divide by a negative 2, divide by a negative 2. Again, these cancel out on both sides, and I would have x equals x. So in this case, when we have something on the left side that equals the same exact thing on the right side, you can say that there's infinite amount of solutions or all real numbers. You could use the symbol R, or you could write all real numbers. So our solution is all real numbers. For 18, they're telling us that the width of a rectangular carpet needs to be 4 feet shorter than the length. So whenever they're giving me kind of a picture of something, I like to draw it that way and know what we're talking about. And they're telling me that the carpet needs to be the width of the carpet needs to be 4 feet shorter than the length. Width needs to be 4 feet shorter than the length. So if we let our length be x, our width then needs to be 4 feet shorter. So I'm going to do x minus 4. Now, since this is a rectangle, we know that opposite sides are congruent. So all of these sides are the same as what's across from it. Now, the next piece of information, they're telling us that our perimeter needs to be 16. So if we recall, our perimeter is when you take each side, add them all up, and when we add them all up, the distance around our whole rectangle is going to be 16. So to set up this equation, I'm going to take each of my sides, so x minus 4 plus x minus 4 plus x, and that's going to equal 16. Now I just need to combine my like terms, so if I look, I have 4 x's, and then I have minus 8, and that's going to equal 16. My final step, I just want to continue and get x by itself. So if I add 8, 4x is going to equal 24. To undo multiplication, I'm going to use division and divide by 4. My 4's cancel out, and I'm going to get x is 6. Now, our last thing that we need to do, if x is 6, we need to go back to our picture. And remember, this x was our length. So we need to just identify that our length was 6. And this x plus 4 was our width. So we just need to identify that that is 6 minus 4, so our width is going to be 2.
Okay, and for the last question, we're told that we have a trail mix made up of 3 different things, raisins, peanuts, and M&Ms. They go on to tell us that the trail mix has twice as many raisins as M&Ms and 1 more than 3 times as many peanuts as M&Ms. So I took a second to just kind of set up the bare bones chart for us. It's a type number value total chart. Here are 3 pieces. Everything's being compared to M&Ms, so M&Ms is my X. I have twice as many raisins, so that would be my 2X. And I have 1 more than 3 times as many M&Ms, as peanuts as M&Ms, excuse me. So 3 times as many M&Ms would be 3X, and 1 more than that would be plus 1. Then I go on to take their prices. So M&Ms is 15, raisins is 8, peanuts is 3. Forget from before when we did that multiple choice question, when you take your number column and you take your value and you multiply them, you get your total. So I should have 15x, 8 times 2x would be 16x, and then 3 times 3x plus 1, I can distribute that in my next step. They then go on to tell me it sells for $21. So my equation would be 15x plus 16x plus 3 times 3x plus 1 is equal to 21. If I start combining some like terms, I have 31x plus, I also want to distribute, so I get 9x plus 3 is equal to 21. I still have some like terms to combine, so 31 plus 9 would give me 40. So I have 40x plus 3 is equal to 21. Now I need to solve for my x, so I get 40x is equal to 18, and when I divide by 40 here, you're going to end up with the decimal 0.45, which tells me there how many pounds of M&Ms I have. I have 0.45 pounds of M&Ms. Now, I didn't exactly answer the question yet, because it did say, what is the weight of the whole package? So if I have 45.45 pounds of M&Ms, then I need to take that and multiply it by 2 to get how many pounds I have of raisins, which would come out to be 0.9. And then I need to multiply it by 3 and add 1 to get how many pounds of peanuts I have, which comes out to be 2.35. So if I take the 2.35, the 0.9, and the 0.45 and add them all up, my final answer is 3.7 pounds, which is how many pounds total I have of the entire mixture. Okay, we want to encourage you to rewatch this video, fast forward, rewind to the questions that you had the most difficulty with, and continue to watch it. We're going to keep it posted for the whole year, so please use this as a resource to help you understand these topics.